All right. So in the last class, we had talked about peer-to-peer architecture, right? So in the end, we had ended the class with what is peer-to-peer architecture, and what we have studied is that in peer-to-peer architecture, the end systems they can communicate directly with each other without the involvement of any server. Okay, so we do not need any server, and as in case of client-server architecture, the server had to be on all the time so that the clients can actually communicate with it. But for peer-to-peer architecture, we cannot expect that to happen. So we do not have any always on server. So what happens is that if this is the case, then there could be scenarios that one client is or one host is trying to communicate with another host, but that host is not on at that time, or it's not available at that time. So at that time, you cannot the other host cannot be served. Okay, so this is one issue. And another thing is that in this case, when you are talking with respect to different hosts, they can have dynamic IP addresses. So if you do not have dynamic, I mean, if you do not have a fixed IP address, so in that case, if you want to communicate or send a request to a particular host, you need to have their address. If their address keeps changing, then that means you have to first find out what is the address of the destination to which you want to send your request, and then you have to send that request, right? So this becomes a very complex process given the amount of hosts that are there in the system. Okay, so the management becomes very difficult. So in this course, mainly we will talk about client-server architecture. Okay, if at all we are talking about peer-to-peer architecture, then I will definitely mention it explicitly. So today we are going to start our class with process to process, basically process communication. That means communication of a process running at one host to another process running at another host. Okay, so we are trying to do that kind of communication here. So first we define process as a program that is running within a host. Okay, so when there are, so you can ask me the question that, what if programs within the same host are trying to communicate? So that we will call as inter-process communication. Okay, and you may have already studied that in your operating systems course. So there are many ways in which inter-process communication that can happen within the same host itself. Okay, so we're not going into the operating systems part of it. We are going to communicate with different hosts. So we have to find out how to ensure that message from one process at a given host is transferred to a process to another host. Okay, so as we know, at the application layer, the message exchange happens um, with respect to messages. Okay, communication happens by exchanging messages in case of the application layer. So here we are going to, as I told you, that we are going to consider clients and servers. So we have a client process. Client process would be the one that would initiate the communication, and server process would be the one that will just wait to be contacted by any client process for a particular communication. Okay, so that's how we define the client process and server process here. Now when you talk about P2P architectures, which we have just seen in the last slide. So applications that work with P2P architectures, they can also define client and server processes with the given definition that has been given here. That means client process is the one that will initiate the communication, and the server process is the one that will just wait to be contacted by the client. However, please note that it is not same as the client-server architecture. It is just that in the P2P architecture, there is a communication that needs to be done. So for that communication, we are simply defining what is the client process and what is the server process for one particular communication. It is not following the client server architecture here. Okay. So this is a very important topic. So please note this. So we are going to study about sockets. Okay. So if I have to define a socket, the definition is given. That is, it is a process that sends or receives messages to or from its socket. Okay. So sorry, it's not the definition of socket. Actually, it is just that what is the task of a socket. Okay. So the task of a socket is that if there is any process which is at the application layer, so it will the socket will just ensure that messages can be sent or received through the socket to the process. Okay. So what is a socket? Okay. A socket actually acts like a door between the application layer and the lower layers. Okay. So whatever data the process has to send from the application layer to the lower layers, suppose here at the sender side, it will be sent via this socket to the transport layer. Okay. So it is simply a door which is just ensuring that once the process sends the message through this door, then it is the task of all these layers to just take care of this message and transfer it to the given destination. Similarly, at the receiver's end, this door, okay, that is between the transport and the application layer. So this door that is called as socket, that basically takes up the information given up from the transport layer and forwards it to the application layer where the process is residing. Okay. Now, whatever is happening at the application layer with respect to the process, that is controlled by the application developer. Okay. And the rest of the part, that is from the transport layer to the physical layer, or these parts or the features with respect to these parts, these are controlled by the operating system and the software related to the hardware, if at all we have any protocol related to that. So I have already mentioned that the socket actually acts like a door, and yeah, I have also mentioned these 2 points, that the sending process will send out message out of the door or the socket, and the sending process will rely on the transport layer architecture, or basically the entire infrastructure that is there below the application layer for just delivering the message to the receiving process. So that's what a socket is. Now, for any communication between two processes, we have two sockets that are involved. One socket will be at the sender's side, another socket will be at the receiver side. Okay. So we will see some more information regarding sockets. Okay. Now, before we see that, we need to see that how do we identify that to which process do I need to send my message. Okay. Now, when we are talking about messages, you can say that okay, fine, there is a source and it can have its address. Okay, so we have a source address and we also have a destination address, so the identification can be done in a similar way. Okay, with the help of the source address and the destination address. But if you see, we are talking from the point of view that we are having a large number of processes, right? So we need some kind of an identifier to find out that which process the given message belongs to. So to receive messages, the process must have identifiers. Okay. Now, what we know is that we know that there is an IP address associated to every device. This is we already know this information. Okay, so an IP address is a 32-bit address. Why do we need this IP address? Because we want to identify hosts over the internet. and this 32-bit IP address helps to um, gain that or achieve that. Okay, so this question I just answered that only IP address, I mean only the address that we have for the host, that does not suffice. We need to have an identifier for a process in order to identify that which process in the particular host are we trying to communicate with. So now how do we actually identify a process? Okay, we told that okay, we need some process identifier, but how do we need to identify a process? So a process is identified by what is called as port numbers. Okay? So port numbers are basically numbers associated with a given process on a host. Okay? So you may have seen these port numbers while you are looking at your browsers. Okay, you can see that if you really want to check it out, you can see in your browsers when you are browsing onto something with HTTP, you will see that what is the port number that is being used. Okay, so in general, the HTTP server uses port number 80 and mail server uses port number 25. Okay, so any application related to related to HTTP server or which is using HTTP server, that will use the port number 80 and mail server will use the port number of 25. Okay, so here an example has been given. So suppose you want to basically access this given website. Okay, so the website of UMass .edu. Okay, so now here you want to access this web server. The IP address is this, that is 128.119.245.12. Okay, now only IP address will just give you the web server. You have to send a particular message to a particular process. Okay, so what you do, you just use this port number of 80. Okay, now what does an application layer protocol define? Okay, so the first thing that an application layer protocol defines is what are the different types of messages that will be exchanged between any two hosts. Okay, so for the main ones are the request and response messages. That is, the one who's seeking for the information will request to the server or the other host for the information, and the other host will basically respond with respect to a with respect to the request that was made by the source host. Okay, so the first classifier is the type of messages that are being exchanged. The next one is the message syntax. Okay, so you are sending a message to another host. Okay, so the host needs to understand that what is it that you have written in your message. Okay, and what is the information that you want. All right, so different fields in the messages are, so we have different fields in a message, and how these fields are delineated, that will be defined in as message syntax. Then we have the message semantics. That means you have different fields to know that what is the message's syntax, what are the information that the message is going to send. Okay, and message semantics is that whatever is written in that message, whether it is understandable or not. Okay, to make the message feels that is being transferred, to make the information understandable, that comes under message semantics. All right. And of course, we have rules which define that when and how processes can send and respond to messages. We also have some open protocols related to application layer protocols, and these protocols are basically defined in request for comments or RFC documents where anyone can access these protocols, just the definition of these protocols. Now, what happens if you have open protocols? It will allow interoperability between different hosts anywhere. Right? Some examples of these open protocols are HTTP and SMTP. Some proprietary protocols, proprietary application layer protocols are Skype and Zoom. Now, see, I told you in the last class that we will look at the properties, the features of different layers in each chapter of this network course. So, first we are talking from the point of view of application layer chapter, right? So, but we are here looking at transport layer service. Why we are looking at this? Because in order to understand the protocol that we are going to study, which belongs to application layer, we need to understand that what is the corresponding transport layer protocol that it uses. Okay, because that is a uniquely identifying factor of that particular of the different protocols that are being used in the application layer. Okay. So, when we are looking for transferring a message from one host to another, what will be the different services that should be provided for this transport of the message from one host to another? So, first is your data integrity. All right. So, that means when you are sending a message from one host to another, it has to be ensured with 100% guarantee that the data has been transferred from the source to the destination in a reliable manner. Okay, so this will basically come under data integrity. Okay, however, there can be some applications that can incur some loss. So in that case, you will not be requiring 100% reliable data transfer, but some amount of reliability will be there. Now, the next service is the timing. All right, so I had given an example sometime back that there can be applications which are very time sensitive, very much time sensitive. So that means when these applications are to be transferred, the time that it takes to transfer these messages from the host to destination, from the source to destination, actually needs to be of large consideration. Right? So some of the applications which have timing constraints with them are internet telephony, that means voice calls, interactive games, etc. Okay? So they want lower delay so that they can be effective. Okay? Now, another transport service that any application would need is a good throughput. Okay, so some applications have a limited or constraint on the minimum amount of throughput that should be given to it. Okay, so there, like your suppose there is an exclusive customer who wants a minimum amount of data rate so that he does not have to wait for any suppose video streaming or any kind of conferences. All right. So in that case, what do? We ensure that a minimum amount of throughput is ensured for a given application. All right. So some examples are multimedia applications which require minimum amount of throughput in order to be effective. Okay. Now the other kind of applications are known as some flexible applications or elastic applications, which do not have such constraints on the throughput. They will just take whatever they get. All right. Now the last one is security. Okay, so we have done security in the last class. So of course we need encryption of data so that very easy spoofing cannot be done, and we need data integrity. Right? So some of the transport services that are required by different types of applications. Some of the transport services, service requirements that are required by different types of applications are given in this particular table. Okay, so you can just take a look at this. One is the first column is for different applications. Then you have data loss, that whether it can actually um, incur data loss or not. That means if there is some data loss, then whether it will affect the application or not. That's what is this column suggesting. Then you have throughput. So here we just it is mentioned that whether a minimum amount of throughput is required for this particular application or not, and whether the application is time sensitive or not. Okay. So if we are talking about file transfer or download applications, then you know that whatever happens, you should not incur any data loss, right? So there should be, there should be no data that is lost in between transmission of this data from the source to the destination. The throughput can be anything. We have elastic throughput. There's no particular strict requirement of throughput. And of course, downloading a file is not a time sensitive application. Okay. Now, similarly, email also. Okay, email, you cannot lose any data while your transmission happens. So you have to ensure that data loss is to the minimum. Throughput can be elastic, and it is not time sensitive also. Now, web documents, if you want to open some documents, so those also cannot incur any loss. They can have elastic throughput, and they are also not time sensitive. Now, next is the real-time audio and video. In real-time audio and video, you can see that these can tolerate data loss. That means even if there is some data that is lost, some frames are lost in between, it does not change much in the overall video. Okay, you can make out what is going on. All right. So real-time audio or video can incur or can tolerate data loss, but what is to be ensured that the throughput must be at least some kbps. So this is 5 kbps to 1 mbps throughput must be there for audio calls, and for video calls 10 kbps to 5 mbps throughput must be provided. Okay? And another is, yes, they are time sensitive. Of course, when you are doing some real time audio or video, the application would be time sensitive, and this time sensitivity, that is a constraint that is around 10 milliseconds. Okay. Now, similarly, all the other applications are also there, like streaming, interactive games, text messaging, etc. So, we have already got to know that what are the transport service requirements for different applications, right, or different types of applications. All right. So what we are going to see here is that what are the services that two main protocols, two main transport layer protocols actually provide. Okay. One is TCP and another is UDP, that is Transmission Control Protocol and User Datagram Protocol. Okay. So here in this slide, we are going to look at what is the service that TCP provides and what is the service that UDP will provide. So TCP basically ensures reliable data transfer between a sender and a receiver process. Okay, so it has some, so it's a protocol, right? So it has some rules that are followed, some algorithms that are there in between, which ensure that reliable transport happens between the sending process and the receiver process. There's also flow control that is provided with TCP service. That means if a sender is sending a lot of data, then it has to be controlled so that it does not overwhelm the receiver. This is known as flow control, and this is provided by TCP. We also have congestion control. That means if so many nodes or even one node is sending a large number of data to the destination, So in that case, the destination will get choked with a lot of data. Okay. So in congestion control, what is done? The sender is throttled whenever the network is overloaded. Okay. So that means if it is found, if the destination founds that okay, the network is getting overloaded and it is not able to receive the data, so it will simply inform the sender that okay, you are probably sending a large amount of data. And even in other case also, the sender also can have some different ways to find out that there is probably a lot of data that is being sent, and that is why there is no acknowledgement that is coming from the receiver side. You know? So we'll read these in detail also. Um, for now, let us look at just the services and how the services are and what are the services that are provided by the TCP and the UDP. Okay. The fourth one is connection oriented architecture. That is, I mean, it's sorry, connection oriented protocol. So TCP is a connection oriented protocol. So what it does, so when we talk about connection oriented, what it means is that before any communication happens between any two processes, then there must be a communication setup that needs to be there before the processes can communicate with each other. Okay. So this is known as a connection oriented process. That means a connection is first established between two nodes which have the corresponding processes, and then once the connection is set up, then the transmission of or the exchange of information can happen. Now, what does TCP does not provide? TCP does not provide timing. So you can see that there is a lot of task that goes on behind any TCP transmission, right? So doing all these tasks does not come for free. So you need to, it takes a lot of time to transfer, I mean, to do all of these tasks before the transfer of data can happen using TCP. Okay. So timing may not be met, and minimum throughput guarantee is not given by TCP, and of course it does not provide any extra security. It does provide reliability, but it does not provide any extra security as such, an extra algorithm that is used so that data is not tampered with. That is not done. Okay. um, So I will just ask a question quickly. So am I clear to all of you as of now, whatever I have taught? If you have questions, you can ask. Okay. All right. So let's get to UDP. So UDP is User Datagram Protocol. So what is the issue with UDP? UDP provides unreliable data transfer. Okay. So between any two processes, the UDP will provide an unreliable data transfer. So with the first point itself, one of you can ask me that, um, if it is providing unreliable data transfer, then why to use UDP? Okay, so that is a question. Now, so see, what UDP does not provide. It does not provide reliability, flow control, condition control, definite timing, throughput guarantees, security, or even it does not ensure that there is a connection setup that is done before the communication happens. So with all of these disadvantages that is given here, why one should be using UDP services? So this is a question. All right. So what is the answer to this question? So see, UDP may not give you a very reliable data transfer protocol, and UDP may not ensure flow control, congestion control, even timing, throughput, etc. Okay, but what UDP can ensure that because all of these unreliability that is there, whenever there is a packet that needs to be sent from the receiver side, the amount of pre-processing tasks that were done on the packet would be reduced or even totally avoided. So all these tasks, they would also take some time, right? So when it comes to UDP, then in that case, when we are using UDP for data transfer, so this delay for all these pre-processing tasks will not be there. Okay, that will be reduced to a significant extent. Okay, so that is why UDP can still be used even though TCP provides a large number of benefits. Okay, so for what kind of services UDP can be used? UDP can be used for internet telephony. It can also be used for interactive games. So until this part, if it is not clear, please you can ask questions now. Okay, otherwise I will simply move forward. Does anybody have any
Ma'am,
questions?
can you explain why UDP is tagging?
Why what?
Why, even though there is more reliable in TCP, why UDP is?
Ah, okay. So see, that's what I'm saying, that UDP, see, UDP does not provide any of these things, reliability, flow control, congestion control, nothing. TCP provides these. But still we use UDP because, see, when you are going to transfer a data and you want to provide, reliable transmission, flow control, congestion control, some throughput guarantee, some amount of security or reliability basically. So in that case, what would happen is it will also take some pre-processing time with it, right? So that is not there in case of UDP. So it reduces the delay to a significant extent, all right? So that is why UDP can still be used. So it can be used for those applications where you will require that the delay is pretty less. All right. Now is it clear?
Yes, ma'am.
All right. Now let's get to securing TCP. Right. Now in the vanilla TCP and UDP sockets, that is the basic TCP and UDP sockets, there is no encryption that is there. Okay, so if you send any passwords over it, it will be simply sent as a clear text. Okay, so yeah, which is not secure at all. All right. So now there is transport layer security that is provided, that provides encrypted TCP connections. All right. So with this, what it will provide? It will provide that your data integrity is also there at the end. When your data reaches the end host, and your authentication is also done at the end system. That is where your destination is. So this ensures, this transport layer security ensures that some amount of security is given for TCP connections. Okay. So now we are going to study web and HTTP. Okay. So when we talk about web, the first things that we do on a web is basically browsing. Okay. So when we browse something, what we do, we simply type a URL and we just press enter, and after that the web page opens. Okay. Now what does a web page consist of? It consists of different objects. Okay, these objects can be images, okay, or even videos. You can see that if you suppose you open yahoo.com, so you will see that there are links to different news, there are videos, there are ads that are popping up. Okay, so and there are even separate images with writings. Right? So each of these parts of the web browser, web page, will be called as objects. Okay, and these objects will be stored on different web servers. Okay, so if you have a particular website, so suppose our IITG web page, okay, if you open that, so there are different images associated to it, there are different texts, links to different documents, videos, etc. are there. So these are basically objects, and these objects are stored in our web server, and the web page will simply uh, consist of these objects. Whenever you are trying to access the URL, along with once you type it, each of these objects will be called, okay, and they will be downloaded to your browser so that the entire web page is open. Okay, so we'll see clearly. We will see what happens. So as I said, that objects can be anything. The HTML file itself. There are many JPEG images. There can be audio files, video files, etc. Now, see, you have, so in your web page, what would you consist of? What would it consist of? It will consist of the base HTML file. Um, then this HTML file will include several reference objects. Okay. So as I told, reference objects can be anything like images, videos, audios, etc. These objects are addressable by a particular URL. Okay. For example, this is your host name. Host name part. Please look at the host name part. So the host name part is basically the uh, exact server that you want to contact with. Okay. So this is the host name. Now within that, you want to get to a particular object, right? So that is given by the path name. So suppose this is www.iitg.ac.in instead of .someschool.edu. Okay. So then you get to CSE department. So slash CSE slash instead of pic.gif, you have a department pic, right, on top of the CSE department web page. So maybe it has been named as dpt.jpg. So in that case, the path name would look like dpt.jpg. So once you try to open this our IITG CSC website, although you will type that, but in between when your web page will be open, your browser is basically calling each of these objects separately. Okay, so your objects are getting um, basically your objects are basically getting called with this particular host name and path name together. Alright. So when we are looking at web browsing and opening web pages and the corresponding objects, so we have to actually talk about the protocol that is used in order to open a particular web page or communicate with a particular server so that you can browse or just request for some objects. Right? So what do we use? The most commonly used protocol, that is HTTP, or the Hypertext Transfer Protocol. Okay. So what is it? It is an application layer protocol. It uses the client server architecture. All right. So whenever there is a communication that has to happen, one will be a client and then another will be a server, and then they will follow the client server architecture. That means once, before establishing a communication, before a communication happens, the communication has to be established in the client server model. Okay, so we'll see how this happens. So yeah, as usual, what is the client? The client will be the browser. So in your system, your browser will be the client that will request or that will receive any web object using the HTTP protocol. And the server will be the web server from which you are actually requesting the objects from. Okay. So as I gave an example, so for our IITG web server will be the server if you want to open our CSE IITG website or even the IITG website. Okay. So this web server will basically send the objects in response to the requests that are being sent out by the client using the HTTP protocol. Right. So yeah, take a look at this. Whenever there is a communication that has to happen between a client and a server, in this case, this is the Firefox browser running on a PC, and it is asking to open some website probably. So the corresponding server will actually respond to it. So before the server responds with the actual data of the web page, what will happen? There has to be a communication that needs to be established, and that is established with the help of this, that is an HTTP request and an HTTP response. So these are messages, HTTP request message and HTTP response message, which are exchanged before um, data is transferred. Okay, so same here. So HTTP uses TCP as its underlying transport layer protocol. Okay. So whenever there is a client that has to transfer data, so what it will do, it will initiate the TCP connection to the server. Okay. So that means a socket will be created. So that socket will transfer this data from the application layer to the transport layer, right? So whenever there is the client tries to initiate a TCP connection, there will be a socket that will be created to the particular server for the particular process, right? So here, what is the process that we are dealing with? We are dealing with HTTP, which has its port number as 80. So our socket that we are creating for our TCP connection, it will have a port number of 80. Okay. Now the server will accept TCP connection from the client. After this, excuse me, after this connection from the client is accepted by the server, then the HTTP messages are exchanged between the browser and the web server. Okay. So browser is basically the client and web server is the server. So we call them as HTTP client and HTTP server here. Now once this transmission is done, then the TCP connection will be closed. Alright. Another property of HTTP is that it is a stateless protocol. That means if it is having a communication or establishing a communication with another host, that is a server, that is basically a server in our client server architecture, it will not keep the states of the clients, okay, different clients and their requests. So suppose there is our institute web server itself, okay. So whoever accesses or opens our IITG website, okay, what is the point of you keeping all of that information, right? We don't need the information of who is opening our IITG website, right? So HTTP is basically using this concept. Okay, the server will not maintain any information about any past client requests. So that is why HTTP is known as a stateless protocol. Okay, so these are very important features. So be very thorough and see in the exams or during even when you give a viva. Okay, uh, I would not like to see that you are just giving some very simple definition of it. I mean, it's not even a definition. I mean, I would not like to see that you are simply just explaining it by using some words. So be very crisp in your answers and use the terms. Okay, you are computer science engineer, so you have to work. I mean, you have to speak accordingly also. Here I'll be using some layman terms so that I would like to I would like you to understand it. Okay, then afterwards I will try to make it more and more complex when I go with the actual technical terms. Okay, so when you are answering, do not use such layman terms. Use very technical terms when we are defining anything. Okay, or when you're writing any answer in your scripts. Okay. So yes, let me get back to this. HTTP is stateless. It uses TCP. Okay, and since it uses TCP, connection has to be established before messages are exchanged. We exchange HTTP messages between HTTP client and HTTP server. All right. Once the connection is done, once the communication is done, then the TCP connection is closed. Right? So this is a brief overview of HTTP. Right? Now, I just told that you know the TCP connection is closed once the communication is done. Okay. Now, with this small property, there is a little difference. Okay, so HTTP is basically categorized into two types: non-persistent HTTP and persistent HTTP. All right. So they have very important characteristics. In non-persistent HTTP, what happens is that once a TCP connection is opened, it will send at most only one object, okay, over this TCP connection. Once the object is transferred, it will close the TCP connection. Okay, so this is one category of one category of HTTP, and another is persistent HTTP. So what happens in persistent? Just the opposite of what happens in non-persistent. That means if a connection is open, until multiple objects are transferred, the connection will still remain open. Once all the objects are transferred, then the connection will be closed. Okay. So the problem with non-persistent HTTP is that, of course, if you are downloading multiple objects, then you will have to every time open the connection, establish the connection, establish the TCP connection, and then you have to transfer the data. Okay, so that is a very cumbersome process. All right. So now my question to you is that if this is a cumbersome process, that is non-persistent HTTP, is there any application that we can use it, or it is simply just like that for you to study? Any answers to this question, that do we actually need non-persistent HTTP? Is there any use of non-persistent HTTP?
Excuse me, ma'am.
Yes.
Yeah, maybe downloading content, because once we have downloaded it, we don't need to make any more connection to the server.
Yeah, that is true. But we are basically looking at HTTP here. Okay, so HTTP is basically, so here we are looking from the point of web browsing. Okay, so if you open a particular web page, there are multiple objects that can be there. All right. So if we use non-persistent in that case, then it will be creating a problem. So can we see something, or can we find something which is still useful? I mean, which makes or where non-persistent HTTP is still useful? Can we find some application?
Ma'am, any static site where user doesn't have many functions to do,
For
like
example,
opening a PDF file online. Like once we have established connection,
mm,
there's not any option.
mm, okay, all right. And any other advantage for a non-persistent HTTP?
Ma'am, in a site, if there are multiple images, suppose, which have to be fetched from various resources. So if we use persistent HTTP connection, it will take a lot of time to load the website. But if we use non-persistent, then the process can be quicker.
The process can be quicker, but you are not receiving the entire data also, no? Entire web page also, no? Okay, okay, this is correct that we can, I mean, if there is just one object, we can simply download it. But tell me something, if I open an object, if I open a connection and after one object is transferred, I stop the connection or close the connection, is there any advantage that I will get from it, from
Ma'am,
this kind of strategy that is being used?
it's like a CPU scheduling. Uh, we don't need to maintain connection for each of the clients that are connecting to the server. We can serve only when the client needs something. So it increases the number of clients the server can serve at a time.
Hmm. Okay, that's an interesting point that you have mentioned. Okay,
Yes.
what's your name?
Arjun.
Okay. So Arjun has mentioned an interesting point here that if there are several clients that a server has to support, then if we are using persistent HTTP, then it has to, the entire set of objects have to be served to the client, and then to one particular client, and then only it is only in the case if it can support only one client at a time, right, Arjun?
Yes, ma'am.
Yeah. So
Uh,
if it has to, I mean, if the service from the server is like it can support only one client at a time, but it has communication requests coming from different clients. In that case, it is a good idea to use non-persistent HTTP so that you can do a scheduling kind of a thing, right?
yes, ma'am. And even if there it can serve multiple requests, it would be, I think it would be more efficient if we use non-persistent HTTPs. I'm like it's analogous to the case where in like multi-core processors where multiple jobs are scheduled between multiple cores doing different tasks. So yeah.
Okay. Okay. All right. So now let's see how the non-persistent HTTP will work. All right. Okay. So here it has been given that a URL is given. That means you just want to get to this page that is home. Okay. So home.index for a given department of this particular server, that is some school.edu. Okay. What does this web page contain? This web page contains some text and 10 JPEG images. All right. So if you're using non-persistent HTTP, how it will work? We know that first thing we have to establish our TCP connection, right? So the client, that is step 1A, it initiates the TCP connection to the HTTP server. Okay. So basically, it is the process at this some school.edu server. Right? So on the port 80. Okay. Then step 1B. What happens in step 1B? The server receives the um, request from the client. Okay, once it receives the request, then it accepts the connection, notifying and starts notifying the client. Okay, I have received your request. Okay, so once the client receives the acceptance or the acknowledgement from the server process, so then what it will send is it will send the HTTP request message that will actually contain the URL, okay, into this TCP connection socket. Okay, all the connections are happening through the connection socket, right? So what the what the client side will do, the client side, once it receives the acceptance or the notification of acceptance from the server side, it will simply send an HTTP request message. What will this HTTP request message contain? It will contain the URL that you want to open. All right. So this URL will be then, this message containing the URL will be sent to the TCP connection socket, and this message will indicate that the client wants this object. So in the path name of this URL, so we just saw in the last slides that what does the URL contain? The host name and the path name, right? So this path name will decide that what is the object that you are basically trying to open. So that will be indicated in the message. Okay. Now this HTTP request message is now being transferred to the client side, or sorry, to the server side. Once the server receives this request message, then it knows that okay, I have to now give back the object that is here, that is some department slash home index, home.index. Okay, so that home page, okay, the information containing 10 JPEG images and some text, that is what the user wants. Okay. Now, what will be done from the server side? It will send that this information as a response message. Okay, what it will do? all the information that was, I mean, not all the information, this home dot index, this information that was asked for, it will put it into the response message, and it will send the message or forward the message to its socket. Okay. Now, once this information is given out, then the server will close the TCP connection. Okay. Now, what the HTTP client will do, the client will receive the response message that will contain the HTML file. Now, after it parses the HTML file, it will find that there are 10 referenced JPEG objects. Okay. So, this is how your non-persistent HTTP will work. Okay. Now, there is, see, if you see here, what was this particular web page containing? It was containing text, and it contains references to 10 JPEG images. Okay. So, once you have received the information, the HTTP response message from the server, what you are receiving in the response message? You are receiving the HTML file, and you are receiving that there are references to 10 JPEG images. Okay, so that means if you have to open the web page, you just got the HTML file, and in that HTML file, it is written that this web page actually contains 10 different JPEG images. Okay, but that those JPEG images have not reached you yet. You just have received that this information is there, that there are 10 reference JPEG images. So in the next steps, for getting these 10 JPEG images, you have to repeat all the steps through 1 through 5. Okay. Again, you have to, establish the connection, and then get the response at the end. Okay. So this is how non-persistent HTTP works, but I will get to the delay and response time, etc. in the next class, because yeah, as you can see, that time is, we don't have much time right now. So any questions?